Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kamal Abdul Osman and my metric number is AF1076. So we are from Group 5 Section 2 for the subject Advanced Foundation Engineering. So our group consists of 4 members, which is the first one is Atira, the second one is Anis Amirah, the third one is Badrul Amin, and the last one is Muhammad Kamal Abdul. So the first one is for the introduction part. So a foundation is necessary for any building. Every project has a foundational component and a geotechnical, which is soil component. The foundation controls the building overall lateral stability, evenly distributes loads, reduce load intensity to stay within the safe bearing capacity of the earth, and prevent the soil movement. So these components all contribute to the solidity of a foundation. The two main factors to consider while creating a foundation are the bearing capacity of the soil and the soil settling. So that's for the company background. So our company name is Geoelectrical Sdn Bhd. So our company was established in September 2018. The objective of our company is to provide the laboratory testing and related specialized services to the civil engineering industry to do any work in connection with any civil or structural work. So Geolab Ikram maintains a strong emphasis on upholding the highest standards of quality, safety and environmental responsibility in addition to its technological capabilities. So next for the organization chart. So for our project manager is Badrul Amin. Our geotechnical engineer is Anis Amirah. The civil and structural engineer is Atira. And the consultant manager is Muhammad Kamal Abdul. So next part for the project background. So our project was located at Parit Bunta, Perak, and proposed to build a water tank tower with a capacity of 100 tons water. So Geolab Ikram Sdn Bhd carried out research on the suitability of foundation depends on the existing soil at the location. So next, the goal of this investigation offers the following. First one is offer the data for determining the type of foundation necessary, which is the shallow or deep foundation. So the second one is the information that will allow the geotechnical expert to give a recommendation on the soil's allowable bearing capacity. The sufficient data or laboratory tests to make settlement and swelling prediction. And the last one is information to identify and find solution of excavation problems.
For a methodology, we use project flow chart to show the overview of workflow for foundation design. So, this is a project flow chart for designing the foundation of a 100 tons water tank tower. The dimension assumption was being utilized within a system software to design a 100 tons water tank tower to prevent structure failure and determine the loads on the column. So, the assumption are the dimension of water tank consists of 4 meter height, 6 meter width, and 12 meter length. The dimension of water tank tower consists of 15 meter height and 12 meter length. The size of the beam is 400 multiplied 500 mm. The size of the column 500 multiplied 500 mm. The thickness of the slab is 300 mm. So this is a 3D drawing generated by the team, which is top view and side view. Next is front view and isometric view. This is the pile foundation key plan, which is show the loads on the column. So we can see that column 1 show the lowest load, which is 817.9 kN. Meanwhile, column 8 shows the highest load, which is 1798.4 kN. For foundation design, we try to do the pile length is 36 meter pile size is 300 multiple 300 meter in a circular shape, and the total of the pile is 3 multiplied 3. So we calculate the load bearing capacity QP, which is we got 395.84 kilonewton. Meanwhile, frictional resistance QS we got 544.50 kilonewton. So the ultimate bearing capacity is 313.45, which is less than the load that need to bear, which is 1798.4 kilonewton. So the single pile is not okay for this foundation. So we try to do the group efficiency. We got 2059.37 kilonewton, which is larger than the NED, which is 1798.4 kilonewton. So the group pile is okay. So the settlement of the foundation is 32.81 mm. It's less than the Eurocode standard 50 mm. So the settlement is acceptable. So the conclusion is this foundation design and acceptable.
Assalamualaikum. My name is Anis Amir Bintan Reza. My metric number AF190048. Today I will present about soil analysis. Analysis of soil properties obtained from bore log. The type of soil from our bore log is the depth from the 1.5 meter to 31.95 meter are clay with the N value of 0, and then from 33 meter to 37.95 meter, the type of soil is silty sand with different N value. At the 40.5 meter to 42.45 meter, the type of soil is sandy clay, and the depth of 49.5 meter to 51.18 meter, the type of soil is very dense with maximum N value 50. Okay, for the standard penetration test, it's a common in situ geotechnical testing method used to assess the properties of soil and determine its engineering characteristic. It involves driving a cylindrical sampler into the ground using a hammer and drop from the specific height. The number of blows such as 30 and 60 required to advance the sampler by a certain distance is recorded and used to calculate the SPT and value, which represent the resistance of the soil penetration. The SPT provides valuable information about the subsurface condition, including the soil's density, strength, and compaction characteristic. It is widely used in geotechnical investigation for foundation design, slope stability analysis, and other geotechnical engineering applications. The SPT result often used in conjunction with other tests and data to evaluate the soil's behavior and make informed engineering decisions. For our project, standard penetration test, we gain from the borehole 2 with the total depth of 55.62 meter with penetration test value 49.50. Okay, the data of soil investigation, C for 17, sigma for 0, E 3.836, PC 70, and CC 2.14. For the Mayoff bearing capacity theory, it is developed by Carl Terzaghi. It's a widely used method to estimate the ultimate bearing capacity of shallow foundation on cohesive soils. It provides a simplified approach for calculating the maximum load a foundation can support without experiencing excessive settlement or failure. The ultimate bearing capacity of shallow foundation can be determined using the following equation, which is Q ultimate equal to QP plus QS. QP is a load carrying capacity of the pile point. QS is frictional resistance. QP we can get from the formula AP equal to AP times QP. AP is area of the pile. QS using alpha method, that's the formula. Okay, for the calculation, Firstly, the specification, we need to determine the NED. We use 1798.4 kilonewton, assuming pile length 33 meter and pile size is 400 times 400 millimeter. The pile gap is 1.2 meter. And then the load bearing capacity for granular soil with SPT value is 1088 kilonewton. For the frictional resistance, we use alpha method. We get QS is 847.33 kilonewton. And then for the ultimate bearing capacity, we use factor of safety 3, and then we get 645.11 kilonewton. It is smaller than our NED, which is 1798.4 kilonewton. So the ultimate bearing capacity is larger, so the single pile is not okay. The pile is need to redesign using a group pile. Using the group pile, we recalculate the QU for group pile, and then we get 2580.44 kilonewton. And then we calculate the group efficiency. The load bearing capacity for group pile is about 2338.55 kilonewton, which is larger than NED. Therefore, the dimension and the quantity of pile is acceptable. And then we proceed to the elastic settlement for group pile. We calculate the elastic settlement, and then we get 40.22 millimeter. According to Eurocode, maximum is 50 millimeter. Therefore, the settlement for this pile is okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Badrul Amir bin Faizi, and I will talk about the discussion and results for this project. From the manual calculation, there are several designs that have been done to obtain the most suitable design. Some of the design is not acceptable in terms of its settlement difference and load bearing capacity. Table presented here is shows the pile length, pile shape, and pile diameter that was designed by our group to obtain the load bearing capacity and settlement. The table shows the calculation for the pile design that we calculate. For the first design, we use the length is 33 meter with square shape of pile. The size is 400 mm times 400 mm with the group pile configuration. For this, we get the load bearing capacity 2038.55 kN, which is larger than the maximum load, which is 1798.4 kN. The settlement for this design is 40.22, which is acceptable because it is below 50 mm. For the second design, we use the length 21 meter, but it used the circular shape pile with the diameter of 700 mm. With also group pile configuration, we get the load bearing capacity of 2187.66 kN. Also with the settlement of 12.01 mm. It shows that this design also acceptable. For the third design, we use the 36 meter pile length and circular pile shape with the diameter of 300 mm, and it is in group pile configuration. We get the load bearing capacity of 2059.37 kN with the settlement of 32.1 mm. It also in range of acceptable values. The last design is the longest pile that we use, which is 49.5 meter with square shape of pile with the size of 200 times 200 millimeter, also in configuration pile, group configuration pile, with load bearing capacity of 2561.98 kilonewton, which is the largest load bearing capacity that we get. But it also obtained the smallest settlement, which is 5.4 millimeter. For the discussion, several factors such as cost, time, and construction method needed to be considered in order to choose the design that will be used in the construction. Especially for this project, the pile design that will be used in the construction is the 33 meter length with 400 times 400 millimeter size that was designed by Anis. The pile used group pile with 2 number of pile per dimension, thus make it the most simple and easy to construct. Pile length of 32 meter is needed to sustain a structure on a very soft clay soil, even though it was a very long pile. Furthermore, the pile design it is slightly safe cost for the construction because it has the less number of pile in group pile configuration compared to the other design. That's all from me. Thank you.
So next for the conclusion part. So in conclusion, completing a soil analysis help with a number of crucial foundation design and building goals. For this project, a size of 400 x 400 mm with a length of 33 meter was selected based on hand competition in order to support a structure on extremely soft soil. So this design option is expected to result in cost savings during the construction compared to the other designs. Despite the reduced number of pile, it is still capable of sustaining a maximum load of 1798.4 kN, and the settlement is within the acceptable limit, which is the 50 mm. So the selected pile designed by Anis with its optimal length, size, and configuration meets the project requirement while considering the factors such as the construction feasibility, cost effectiveness, and safety. That's all. So that's all from us. Thank you.